Good morning, Year 4. Going to continue our learning on angles this week. But before we move on to the next step, just want to go over what we did yesterday. We looked at naming angles yesterday, looking at acute, obtuse, and right angle. So an acute angle is anything less than 90 degrees. For example, 30 degrees is an acute angle. The angle is here. So we can signify or symbolize an angle by doing that curved line. So we know that this is a 30-degree angle. 60 degrees, twice as big, but it's still an acute angle. Then we get to 90 degrees. Now you can see this is a curve, but what we usually do when it's a right angle is to draw in a little square like that to show that it is a right angle and to show that it is 90 degrees. And then between 90 and 180, we've got our obtuse angles. So that goes all the way up to 179. And then 180 degrees, you can see, is two right angles, or it's half a turn. And I want to concentrate on that. So when it's a straight line, so when we've gone from, when we've gone from 0 and we've gone all the way around, that's a straight line, and that is 180 degrees. So I've got a straight line here. I've put 3 toothpicks together, and I've got a straight line. So my angle there is 180 degrees. Now, today, we're going to be learning all about triangles. And I'm going to tell you that all the angles inside a triangle are always add up to 180 degrees. I'm going to show you why. So I'm going to take this straight line. I'm going to turn it into a triangle. So if that's an equilateral triangle, meaning that all the sides are the same, that means that this angle here would be 60 degrees. All right, 60 there. This one would be 60 degrees. And this angle would also be 60 degrees. 60 add 60 add 60 is 180. So that is why all triangles add up, or the angles on the inside always add up to 180 degrees, because a straight line is 180 degrees, and through that straight line, we can then make a triangle. So here I've got a type of triangle. It's an equilateral triangle. And some of you already may have seen the root word, which looks a bit like equal. So equal means the same as. Lateral actually means side, so equal sides. So all triangles have 3 straight sides. The word tri, Latin, 3. So triangle has 3 sides. And we can show that they're equal by doing this. So that side is the same as that side, and that's the same size as that side. Now, an equilateral triangle also has 3 identical angles. So if we get a protractor and measure, let's make it a bit smaller. So if I measure this angle, you can see that this angle here is 60 degrees. And then Ooh. Oh, shoot. Let's do a new one. Let's measure it like this. See, that angle, again, is 60 degrees. And then measure the top angle. Oops. Let's move it there. You can see that again, it is, move that perfectly on the line so we're nice and precise. Again, it's 60 degrees. So 60 at 60 at 60 is 180 degrees. But an equilateral triangle mainly has all the sides are the same length. No matter which way you rotate it, all the sides are exactly the same length. Let's look at a new triangle now. The next type of triangle is an isosceles triangle. And I just did a bit of research, and isosceles comes from Greek. As we know from our first unit of learning back at the beginning of year 4, lots and lots of words we still use today comes from the Greek period. So isos means equal, and skelos means leg. So when you put those together, look, isosceles or isosceles, whatever. So isosceles literally means equal legs. Now, what's special about a isosceles triangle is the fact that it has 2 equal sides. So 2 of the sides are the exact same length. This side is longer, which also means that 2 angles are the same. So let's look. They have to add up to 180 degrees. So if we measure the top one first, let's rotate it all the way around. Put that on the line and bring it round. You can see actually that is a right angle, isn't it? So we've got a 90-degree angle, which means these two have to be the same. You might be thinking, well, actually, if the angles on the inside add up to 180, one of them is 90, and this is the same. What is the value of the 2 missing angles? Let's see. Let's move it down to here. So that's a 45-degree angle, which means the other one has to be 45 degrees. Let's just see if it does. Perfect. So 45 add 45 is 90, and 90 add 90 equals 180 degrees again. So an isosceles triangle has 2 sides that are equal and 2 angles that are equal. And our next type of triangle is a scalene triangle. I just did a bit of research, and again, it comes from the Greek language. So skalenos, I think that's how you pronounce it, means unequal. And actually, that's exactly what a scalene triangle is. All the sides are different sizes or different lengths. So this triangle here, the top one, every single side is a different length. And again here, every side is a different length. And all the angles are different as well. They will still add up to 180 degrees. But all the angles, are completely different. Maybe we could use a protractor to work out these angles. Let's work this one out. So that's 50 degrees. Hope this works now because I've drawn this triangle myself. And this compass, I keep saying compass, this protractor only does intervals of 5. Let's see if it works. 25, which means 50 add 25 is 75. 180 take away 75 is 105, which means this angle should be 105 degrees. Let's see. Perfect. So you can see every side is a different length, and every angle is a different size. So that's a scalene triangle.